that we're going to work on, part C, is just in calculating the ideal gas constant with different units than we usually do it with. So we measured the volume of the flask. So what we did was we took, filled it up with water, and then up to a line, and then measured how much water was in there. Great. I got mine to be about 155 milliliters. Yours might be a little bit different. That's okay. Now, the next thing we want to do is go back over to here. Okay, so this is the R. We're going to calculate. So PV equals nRT, so R is equal to PV over NT. So we're going to take the volume that I just said, the 155 mils, and then we're going to take the room pressure and temperature. So we're going to go back to table 2. Here's my table 2. So I'm going to pull out that temperature, 294.95, and then the 14.6633 for my pressure. So I'm going to take the room temperature pressure from part B, from table 2. That's what you're going to calculate the ideal gas constant with. So that's where I get my volume, my pressure, my temperature. And now I want to find the moles. So to find the moles, they give us a whole bunch of information. They tell us that they give us the density. So if I know the density and I know the volume, I can use that to find the mass, right? Density is just mass over volume. So that's the first thing I'm going to do. So I'm going to determine the mass of the air in the flask. Okay, so I know that the density is, let's type it, density is equal to 0.00119 grams per milliliter. Okay, so that they give that to you in the problem. And they also, we just found out that the volume is equal to 155 milliliters. So if density is equal to mass over volume, then mass is just equal to density times the volume, or volume times density. So I just have to multiply those two things together here. So I'm going to get my 0.00119 grams per milliliter, and I'm going to multiply that by the milliliters, the 155 milliliters. And when I work that out, my milliliters are going to cancel. I'll end up with grams, and I got 0.18445 grams. So that's the mass of the air. So I'm going to put that here, 0.18445, and that's in grams. And now to find moles, I need to know the molar mass. So if I know grams and I know how many grams I have per mole, I can figure out how many moles I have. So that's what we're doing in step 2 here. They tell you the molar mass is this. It's 20. I'm just going to copy that. is 28.965. I'm going to find the moles. So if this is my molar mass, great. I can take these grams, this 0.18445 grams, and divide by the molar mass, 28.965 grams per 1 mole. And when I work that out, that should give me the moles of air, 0.00638 moles. And now I think I have everything I need. So I've got, and I'm going to put that up here, I've got 0.006368 moles. Great. Now to find R, I need the volume, which is the 155, right? So I have my volume. Just type everything down here. Okay, so I got my volume is 155 milliliters. My pressure that I'm going to use, I stole that from table 2. Just going back over to table 2, this is my pressure. I'm going to do 14.6633 psi. So I got 14.6633, and that's in psi. My temperature is the room temperature. Water here, this bath right here, from table 2 again, 294.95, 294.95, that's in Kelvin. And then the N is what I just calculated, the number of moles, 0.006368. So this, cool, so I calculated the moles. That was the hardest part. Oh, and of course it's making it capitalized. It's just those are the moles. Great. Now I can just plug that into R, right? So R is going to be the volume. So R is just going to be that volume, that 155 milliliters, divided by multiplied by the P, 14.6633, and that's in PSI. And then on the bottom, I'm going to have my moles, the N, 0.006368 moles times 294.95. So instead of liters atmospheres per mole Kelvin, I end up with milliliters psi per mole Kelvin. And when I work all that out, I get 1210. Great. Now that was my R that I got. Now they tell you in the lab, so if I go back over to the procedure, they tell you that the expected value is, you know, it's 1206, basically 1206 if I get rid of this times 10 to the 3. So then I can calculate the percent difference, and this is how they tell you to calculate the percent difference. So I can copy that over. There's a few different ways. We'll do it this way. Great. So my calculated value there is the 1210. So I have my percent difference is going to be 1210. The expected was 1206 divided by the expected 1206 times 100. And when I work that out, I'll put this in parentheses. It's pretty close, pretty close there. I end up with a 0.33 percent difference. So that's really good. Cool. That's my final answer there, 0.33%.